Remember doing solving equations? Maybe it was 10, 12, 15, 20 15 problem sets. It wasn't 20. Actually, it could have been 20 problem sets ago you were solving equations. Okay, are you still an expert at it? If you're an expert at solving equations, I can tell you this is going to be a beautiful, beautiful session today. If you're not an expert, it might be a bit more hard work. So let's check. Off you go, solve these three. See what you come up with. And to give you a hint, a helping hand, the technique I'll go, you might be a balancing person, but I'm just going to stick with change side, change the sign. That's the hint I'm giving you. So off you go. You solve them. All right. All sorted. You paused. You had to go. You sorted, done all three. Maybe number C was a bit part C was a bit funny. A and B sorted. Let's do it. Let's do it together. Change side, change sign. I want x all by itself. That's the game of solving, finding the value of x. So I'm going to write 6x is equal to, and it's that minus 7 that's going to go on the other side. And if it goes on the other side, minus 7 becomes positive 7. Did 5 go anywhere? No. It's only the 7 that's moved. 5 stays. So we have 6x is equal to 5 plus 7. Now we can work it out. 6x is equal to 12. And change side, change sign. Right now, that 6x means 6 being multiplied by x, or x being multiplied by 6. What's the opposite of multiplying by x? Multiplying by 6, we're going to keep the x, but the multiply by 6 has to go on the other side, which means it has to become divide by 6. 12 divided by 6, which means that x is equal to 2. Oh, yeah. Yeah, we're feeling this. If anything, we're not feeling the size of my writing, and we can just drag that over there, nice and neat. Now for B. For B, you don't have to, but probably the method you're thinking about is expanding the bracket first. I don't want to reality in this particular case. We can do it differently, but we'll err on the side of caution. We'll expand the bracket. We'll multiply out. So we get 4x. Take away 8 is equal to 20. Now change side, change sign. 4x is equal to 20 plus 8. The minus 8, that's what's happened. Minus 8 on the left has gone over and become plus 8 on the right. So now we have 4x is equal to 28. That multiply by 4 becomes divide by 4. X is equal to 28 on 4. Fraction bar means divide. X is equal to 7. So that's the answer to the second one. Did I need a bit more space? Wow, 2 on the trot. Did you have 2 sorted just like that, just like that? Did you see how I did those? Went in and boom, 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 boom. Got it sorted. Okay, right, so we got 2. Let's deal with the third. The issue here that makes it a bit different is that we have not 6x, we have negative 6x. But we need our x to be positive. So that minus 6x needs to go to the other side. So what I'm going to have is minus 6x will become positive 6x. I haven't done anything with the minus 19 as yet. That will stay there. And then 5 is what's on the left-hand side. So 5 is still on the left-hand side. At this stage, I want all the numbers on the left. The 6x has to be by itself. So that minus 19 needs to come over and become positive 19. So I got 5 plus, don't want to make the illusion that the 5 has moved, so it's 5, and then we have plus 19, and all of that is going to give me 6x. The 6x, the positive 6x is all by itself. 5 and 19, well, that is 24. So we have 24 is equal to 6x. That means that x is equal to 24 divided by 6. The opposite of multiplying by 6 is dividing, which gives me x is equal to 4. And feel comfortable with that. Sometimes the letter is going to be on the right hand side, x equals 4. At the very end, very last stage, if you want to change the order, you can. Because that's really the convention. She probably should. I'm not a big, it doesn't matter for me, but x equals 4, that's your answer for C. X is equal to 4. And in all these cases, I've been naughty. What have I not done that I should have done? That you always do, that you've done already. You check your answer, you do substitution. 6 twos are 12, take away 5, 7, take away 7 is 5. 7 take away 2 is 5, 5 fours are 20. 6 fours are 24, 5 take away 24 minus 19. We're happy. You make those checks, use substitution. Now, big moment. Learning objective was to be able to solve linear inequalities. Look carefully at what we've done here. I'm going to give you 5 seconds. Look carefully at the questions. Look carefully at the working. Are you ready? Are you ready for this? Boom. Here you go. That's what you need to do. What's different now? You'll see that now has the inequality symbols. We're now saying that 6x minus 7 is not equal to 5. We're saying 6x minus 7 is less than or equal to 5. We're saying 4x take away 2 in brackets is greater than 20. We're saying 5 take away 6x is greater than or equal to minus 19. So when we solve, what do? We're no longer finding a specific value of x. We're finding a range of values. X has to be above, greater than, or less than this particular number. How do I do that? Change side, change sign. In other words, you do exactly what we did before. The only difference is that instead of an equal sign, you will have an inequality symbol. So 6x is less than or equal to 5 plus 7. 6x is less than or equal to 12. X is less than or equal to 12 divided by 6. X is less than or equal to 2. I did it that fast just to bring home the idea. You're not doing anything new. You're just doing exactly what you've done if you said it was an equation, but you're using the inequality sign. Don't believe me? I expand the bracket. 4x take away 8 is greater than 20. That means that 4x is greater than 20 plus 8. 4x is greater than 28. X is greater than 28 divided by 4. X is greater than 7. Exactly the same work, exactly the same thought process as solving an equation. The only difference is instead of an equal sign, you have the inequality symbol. Think you can manage doing an exercise on this? I think you can. I think you can. What's the answer for C? We do. Greater than or equal to the minus 19 plus 6x. The 6x moves on to the right-hand side. 5 remains. Then the minus 19 needs to go on to the left-hand side, giving me 5 plus 19 is greater than or equal to 6x. The symbol, we just keep using the same symbol. Greater than or equal to x will be 24 divided by 6. I skipped a step there, got ahead of myself, but 4 is greater than or equal to x. X, in other words, we're saying x is a number less than 4, less than or equal to 4. If it's 4, it's going to work, or it has to be less than. That is the big idea of solving linear inequalities. In terms of solving the equations, it does have some additional ideas that we'll explore in another lesson, but for this lesson we just want to practice and drill how do you come up with the range of solutions. In other words, we want to practice more the same technique that we practice for solving linear equations. Exercise comes up now. Nail it. Here are your first set 6 questions to do. Off you go. Pause the video and work through these, please. Pause and work through these, please. Okay, I'm going to put up the answers. Before I put up the answers, I just want to touch on E, because E is one that we haven't really, we didn't do as an example with the fraction. The fraction means dividing by 4. We want to get rid of that divided by 4, which means you need to first step, you'll multiply both sides by 4, giving you 2x take away 6 is less than or equal to 4. That's the first thing you will do. And then that means that 2x is less than or equal to 4 plus 6, which is less than or equal to 10. 2x is less than or equal to 10. So x is less than or equal to 5. That's what you're going to get for E. Okay, let's just get all the answers up, and you can see x is less than 5 as expected. So it was the use of the fraction, just multiplying both sides by 4 would have sorted that out. And let's get ourselves an even bigger problem set now. Here are 12, 4 threes are 12 of them to do. Remember, change side, change sign. Stick with that. Some of the answers might be fractions. That's okay. It's not always going to be whole numbers, and you'll probably get some negative values as well. Pause, dedicated practice, make it happen. I'm going to put up the answers for you now. You've worked on it. You're happy at what you've done. Have you done checks for yourself? Because remember, you could check for yourself by substitution. You've done that. Let's compare. These are the answers you should have. Lots more fractions than these, so much more complex numbers, but how did he get on? Good stuff. And now we have a new type of inequality that we need to deal with. And I've made a quick note on it. This idea where we have three sections. The left, that's the way I reframe it. So the lower bound, I'm not getting this, the lower bound, and then you have the upper bound. I just call it left, right, and then the expression in the center. And that idea, we just want to keep doing the same operations to get x all by itself. So for example, I'm going to take away, first thing I want to do in the middle is take away 2, and whatever you do to the middle, you have to do to the right side, the upper bound, and the left side, the lower bound, exactly the same thing. So what I'm going to end up with now is 6x. The plus 2 take away 2, neutral, it becomes 0, is less than or equal, so yeah, is less than or equal to 30, and then is greater than minus 10 minus 2, which is minus 12. So far so good. And then I don't want 6x, I want x, so I'm going to divide. Now I'm dividing by 6, which means I need to divide the upper bound, the right hand side, and the lower bound, the left hand side. They all need to be divided by 6. At this stage, I will get x in the middle. 30 divided by 6 is 5. 12 divided by 6, or minus 12 divided by 6 is minus 2. So those are the range. That's the range of values that x can take based on this inequality. X can be greater than 2 or less than 5. Any number greater than 2 or less than 5 will meet this criteria. We can try 0, be less than 5. 0. If x was 0, it would be 2 in the middle, and 2 is less than or equal to 32 is greater than minus 1. If x is minus 2, then we'll get minus 12. Minus 12 plus 2 is 10, which is the limit, so it has to be greater than 10. We know if it was minus 2, will be equal to 10, which means that doesn't meet the requirement, so it has to be greater than minus 2. And that's it. That's the strategy. We're thinking about the middle, and whatever we do to the middle in terms of add, subtract, multiply, divide, we do to the other, to the upper bound and the lower bound. I think instead of left and right, I will call U for L for lower, and then U for upper bound, and then the E is for expression. That seems a bit better than the left. I should have stepped with left, right, center. Hopefully it makes sense. Let's. Before we get into this same operations, we need to expand the bracket, so we need to manipulate the algebra. This will give me 3x take away 9. So I have 3x take away 9 is less than or equal to minus 14 is greater than minus 24. I don't want 3x take away 9. I want x. So the first thing I'm going to do is add 9 to the expression, and that means I need to add 9 to the minus 14 and the minus 24. Now, if I deal with the upper bound, the minus 14, if I add 9, that's going to get me really close to 0. It's going to leave me with minus 5. And then we'll have 3x in the middle, and then the minus 24 plus 9, that's going to be minus 15. Now I have 3x, but I want x, so we're going to divide each term. We're going to divide the upper and the lower bounds and the 3x by the 3. And dividing x, that will give me x. And then the lower bound is going to be minus 15 divided by 3, which will give me minus 5. And then the upper bound, minus 5 divided by 3. We can't do that division, so we leave it as a top-heavy fraction. I'll say that again. If the division won't give you a whole number, then feel free to leave it as a top-heavy fraction, and that will happen. So I have, for part B, x is less than minus 5 on 3. It is greater than minus 5. I have some for you to try now. You got 6 of them. Have you go. Have you go. Have you go. Work on these. Remember, it's video. You can go back and watch what I did, but you work on these. Follow that strategy in terms of managing the 3 sections. You've had the power of the pause. You've looked at it. The big moment now. I'm going to put up the answers. After 1, 2, you can still pause and do more. Here are the answer. Here are the answers. Wow, pen is still on, so that won't work. Here are the answers to the question. I still had some of the questions there. We don't want the questions. We just want the answers. Yeah, so for the last two, E and F, let me just write in the letters E and F. You saw you got the fractions. F being the most uncomfortable. This fraction has been simplified to get a half. 4 on 8. Is it 4 on 8? Let's just see. You would have had. Yeah, we'll leave it at that in terms of getting the half. Should I do that one for you? Yeah, I'll do this one. I'll finish off by doing F so you can see it in detail. We'll expand. We'll get we'll get 8x. 8x take away 12 is less than or equal to 3 is greater than or equal to -8. At that stage, we're going to add 12. Let's just keep my notation. We're going to add 12 to everything. Add 12, add 12, add 12. That gives me less than or equal to 15. And then we have 8x in the middle, and that's greater than or equal to 4. And now we have to divide throughout by 8. So dividing throughout by 8, each term being divided by 8, that would give the answer that we just saw. 8, usually getting 4 on 8, which is the half. 4 on 8 is what you'll get for the half. And then the 15 on 8, which was the upper bound. So 15 on 8 as your upper bound, 4 on 8 a half as your lower bound. And that is your introduction. A very good introduction and going very far into linear inequalities. There are a couple more ideas that you need to be totally exam ready for this topic. But if you've got your head around these, you're in a very, very, very good position. Take care for now. Bye-bye.